At what point or points in the interval 0 included, 2 pi not included, is the tangent line horizontal for f of x equals cosine squared x plus sine x? A horizontal line has a slope of 0. The slope of the tangent line is the derivative, and we want to find where that's equal to 0. So we're going to be taking the derivative of f of x equals cosine squared x plus sine x. Before we take the derivative, let's rewrite that cosine squared of x as cosine of x quantity squared so that we can see how to take the derivative for that term. The derivative, f prime of x, will be the first term is the power rule to start off. Bring the power down, leave the inside alone, subtract 1 from the power, and then multiply by the derivative of the inside to complete the chain rule. And then the second term, the sine of x, the derivative will be cosine of x. Let's make this look a little nicer here. I will bring this negative to the front with the 2. Negative 2 cosine x sine x plus cosine x. And we want to find where we have horizontal tangent lines. This is the slope of the tangent line anywhere. Horizontal lines have a slope of 0, so we're going to want to look at where this is equal to 0. So we have to solve this result. Now, nicely, we do have a common factor on the left side. A cosine x can factor out. So we'll have the cosine of x times a negative 2 sine x plus 1 is what will be left over, equals to 0. Since we have two factors multiplying each other equal to 0, one of those has to be equal to 0, so we set each of them equal to 0 separately. This one here will have to take a few more steps to be able to solve. Let's subtract 1, and then we'll divide by the negative 2. The negatives can cancel, and so sine x equals 2 1/2. Okay, so we're going to be solving where's the cosine equal to 0 and where's the sine equal to 1/2 between 0 and 2 pi. Well, the cosine is 0 when x equals to pi over 2 and 3 pi over 2. And the sine is 1/2 where x equals to pi over 6 and 5 pi over 6. Now that we've come up with all the x coordinates, we want the points, we want the y coordinates, so we're going to find the y coordinates to each of these. So x equals to pi over 2. The y coordinate will be f of pi over 2, which is going to be the cosine squared of pi over 2. That means to take the cosine of pi over 2 first and then square it, plus the sine of pi over 2. Plugging back into the original function. Cosine of pi over 2 is a 0, 0 squared plus, and the sine of pi over 2 is a 1. 0 squared is 0 plus 1, and that'll give us a 1. So we have the point pi over 2 comma 1. We also have x equals to 3 pi over 2. Let's find the corresponding y coordinate by plugging in 3 pi over 2. And that'll give us the cosine of 3 pi over 2, quantity squared, plus the sine of 3 pi over 2. Well, the cosine of 3 pi over 2 is a 0, so 0 squared. And the sine of 3 pi over 2 is a negative 1. So we have a 0 added to a negative 1, which is a negative 1. So we have the point 3 pi over 2, comma, negative 1. We have two more x coordinates. We have x equals pi over 6. The corresponding y coordinate will be f of pi over 6, which is going to be the cosine of pi over 6 squared plus the sine of pi over 6. Well, the cosine of pi over 6 is root 3 over 2. We have that squared. And the sine of pi over 6 is a 1/2. Now, root 3 squared is a 3, 2 squared is a 4, and we're adding it to 1/2. Well, I'm going to rename that 1/2 2/4. I'm going to multiply by 2 over 2 for the common denominator. And I'm getting a 5/4, so I have the point pi over 6, comma 5/4. And then last of all, we have x equals to 5 pi over 6. Our y-coordinate will be f of 5 pi over 6, which will be the cosine of 5 pi over 6 squared plus the sine of 5 pi over 6. The cosine of 5 pi over 6 is negative root 3 over 2 squared. The sine of 5 pi over 6 is still a positive 1/2. We're in the second quadrant for 5 pi over 6. Negative root 3 over 2 squared. A negative squared is once again a positive, so this will again be 3 over 4 plus, and I will rename 1/2 2 over 4. And this also has a y-coordinate of 5/4. So we have 5 pi over 6, comma 5/4. And there's our 4 points where we have a horizontal tangent line to the graph in the 0 to 2 pi interval.